Yeah, welcome to our webinar today at the facility at FACC in Austria. And with me I have Stefan from 11 Dynamics and Felix from Neobotix. And my name is Jan, I'm from API, and I'm happy to have you on this webinar today. So what about the webinar topic?
The topic is how we can bring hardware together and drive it with our 11 Dynamics Automation Suite software to do automatic measurement tests for big parts.
Big
Yes.
parts.
I heard that there is something from API which can do and handle something like that.
Oh, thanks that you introduced API, and maybe I just take the opportunity to explain a little bit more about the solution of API. Most of you may know API as one of the leading companies providing metrology equipment, and one product line is our so-called 9D laser. It's a scanning laser system which is used for large volume scanning applications with a high accuracy, high speed measurement, and also quite insensitive against surfaces. This characteristics allows us to really measure automatically surfaces, features from small volume to large volume. And I guess especially today the large volume is the main topic, as for sure everybody knows the scanning systems, and you see it also in the background. The laser is scanning this, the winglet. But at the end, the challenge is always how I can do not only one position of the scanner, how we can relocate it, and as Stefan said, it should be automated, it should be autonomously, and that's the solution I can bring Felix from Neobotix, because they have a solution how we can relocate our laser.
Jan, thank you very much for the introduction. Yeah, we at Robotics, we build mobile robots, autonomous robots since more than 10 years already. Our specialty is basically building niche applications, customized robots for particular applications like this one here. We have a modular system where we can provide all sorts of kinematics, sensors, technologies and software suites to navigate and position the systems. Interesting here is actually that, as Jan just mentioned, together we can create actually more value in the combination of the technologies. Mobilizing the scanner, relocating it to a different position, really helps actually creating an autonomous scanning process, basically, which you don't have to touch anymore. But once you have set this up, you might want to change it later on, and if you have some experience with automation, you know that changes later on might be a little bit difficult, or at least they were until today. But today we have 11 Dynamics with their software suite with us here, and that's working out quite well, so that can be adapted easily, and I think Stefan can tell us a little bit more about it.
Thank you, Felix. With our 11 Dynamics Automation Suite, we provide the software to connect the two hardwares together, so we can import the HEV and drive the HEV in our software. We can import the API sensor and mount it more or less like we have it here in this situation on the HEV from Neobotix. Do all the simulation in our software, do the path planning, we really get the cycle time out of our software, where we have to locate the HEV to get the perfect data, and later on we can drive it with our software, do all the measurement tasks, forward everything to the inspection software, so it's an absolutely automated solution for big parts.
You can go from actually simulating to actually creating the code to run the whole system.
Yes, we can do everything. So before you really buy something and try it in the reality, we can everything simulate, build up in our software. Even if you have a scan from your wall, you can put it in our software, so you know all the ways where are some obstacles and things like that. So perfect solution, easy solution.
Easy, sounds easy, but just to recap, so that means we have an empty hall. We consider to set up a measuring cell or a solution, And before we start to build anything in this hall, we use a white paper or a white screen. Maybe it's more a screen. And say, okay, that's the hall. We did a scan before or did some CAD models. We have the CAD model of the piece. We have our kinematic models of the robot and of the laser. We simulate everything. We know how fast we are, where we need to go, how the scanning path looks like.
Yeah, we get the simulated data. That means we already know if we have to relocate, let's say, the sensor, the hardware, to get perfect data from each position. So we can do the whole planning in our software, simulate it, get simulated data, send it to the inspection software, let's say, create a simulated report out of it. Everything is, let's say, locked and fine, works fine, and then we can go to reality, build it up.
Sounds interesting. That means, I said you talked about it earlier today, before we did the webinar, the return of invest is already calculated.
Yes.
Before we have any contract signed.
That's right, and the robot, the HEV, is moving 3 shifts without any complaints, also the API, so that means you can run it 24/7.
That sounds good. Find an employee who runs 24/7.
And he's always and he's always motivated.
Keep him motivated. Yeah.
Keep him motivated.
But if you talk about employees, if it is fully automated, that means the impact of an operator, which is unfortunately one of the uncertainties for all the measurements, can be eliminated.
Yes, can be eliminated. And also the operator now can really get into the nice things in his job, do some evaluation, do some new inspection tasks and things like that. Important stuff instead of just moving a scanner from A to B or something like that. I think that's maybe a little bit boring for a radiologist.
I think that's maybe mostly relevant for the handheld scanners, right? I mean, like API has handheld scanners as well, but I think for the handheld processes, like the human factor is probably like the biggest one. I mean, like we could also integrate that on a mobile robot, and then also in these handheld processes fully eliminate the human factor here. So we get to the maximum of stability.
Yeah. We even can combine it, so we can, let's say, take 2 HEVs from you. On one, the API laser is mounted. On the second one, we have a cobot with an hand scanner, and we can combine everything together in just one measurement task.
So we can even speed up the cycle time using 2 systems more or less simultaneously, depending on how the interface looks like.
Yes. That depends more or less on the inspection software. If the inspection software is capable to get data from 2 hardwares simultaneously, it's easy.
It sounds like a great solution.
It is.
Yeah. So what should be a root cause or a reason to not buy it?
Maybe you don't have the right part, it's too small.
Yeah,
but otherwise, I think there is no reason.
But I think that's right. This kind of solution is exactly what is needed for large volume. If you have parts from the aerospace or wind energy sector, I think that's a great solution. If you just have a small piece, maybe it's a little bit oversized.
Oversized, right. Yeah. You should stick to a hand scanner.
Maybe, yeah. But you cannot eliminate the operator.
That's right, that's right. But we can mount it on a cobot.
Okay, but I think you saw in the background, we have an HEV running back and forth just to showcase a little bit how it works. For sure, the reality will be a little bit more complex. But as Stefan said, the software gives us the opportunity to really simulate, or I think the official English name is a digital twin.
Yes, we build up a digital twin in our software, and we can simulate everything with this digital twin.
Sounds great. So in this case, I think, do you want to add something else?
I would ask you, like, how long does it take to build the digital twin, basically? I mean, the setup and the integration, we did this here in a couple of hours, but the digital twin, like in a regular project, what do you think?
It depends on the size and the complexity of the cell, but it's just drag and drop. You take our library, you take the robot, drag it into the 3D scene, you take the sensor, it's already mounted on the robot on the correct position, you take in the part and that's it, and then you just generate the path. You can do it by auto feature. If you have a CAD file, just click the features you need and say generate path. Easy task.
Yeah. Sounds great.
It's a lot of fun. It's like a Technic Lego for adults.
So it's not metrology anymore.
No,
it's just playing a little bit with scans.
Yes, enjoying.
Okay, but you see, the combination of different systems, hardware systems or sensors is always a challenge, but with the right software, it can be done easily. We can do this full automated simulation, the digital twin. You see the result we can provide, and then we have a great solution. And yeah, if there are more questions, especially to the software, I think Stefan is more than happy to answer it. Felix can give us more details about the robots, and if it's about the API laser products, feel free to ask me directly. And yeah, I think hopefully we can answer all the questions you have.
We will do our best.
We're going to do our best.
See you in the Q&A session.
See you. Yeah, see you.
Yes. So hopefully you enjoyed the video and the discussion between Felix and Stefan and myself. So I appreciate the participants here. And I guess we may already answered a couple of questions, but for sure there might be individual questions which can be raised up yet. As usual in such kind of Zoom meetings, please use the chat or the Q&A functionality to write your questions. And Stefan, Felix, or myself can answer depending on the topic you ask for. So feel free to ask your questions. And if there are no questions, as usual, I guess we did a great presentation and everything is cleaned up. Just need a few minutes to type. Let's see. Here's the first question. Do you plan to show a demo of how we did the offline programming with the automation suite, EDAS? Stefan, I think that's
my part. Yeah. I think the easiest way will be just get in contact with us, and we will set up an online meeting where we can demonstrate our software, the capabilities, how to do the programming and things like that. I think this is the easiest way. We also have on our YouTube channel some tutorial videos, and you can download a trial version for 30 days. So it's up to you, but I think the easiest way is get in contact with us and we set up an online meeting and show you the capabilities of our software.
Okay, I think this answered the question. There is another question in the Q&A. How is the robot cart coping with uneven shop floors and cables on the ground and etc.? I think, Felix, that's something for you.
Yeah, thanks for that question. In general, we are able to cope with a couple of centimeters of obstacles or like little ledges there. In general speaking, it should be like a even surface, right? So if there are big holes or major structures the way, it's of course not possible. Cables, well, I would say like it depends. Like if it's a small cable, we can run over it, but ideally there are no cables in the exact location or position where we want to end up and drive through.
Okay, there's an additional question also for you, Felix. What's about space or obstacles and people running around in the area you are driving the HGV?
Yeah, I mean, that's to be specific, it's not an AGV, it's an AMR, so autonomous mobile robots. We don't follow a particular path which is predefined. We can navigate freely in room. So if there's an obstacle in the way, we can round past it and the robot find its own way around it. Same goes for people. If people are detected as like dynamic obstacles, basically, so if something's crossing the path, may that be a stapler or a person walking, the robot stops and only continues if the obstacle is out of the way again, or stays in the way, and then it slowly maneuvers around it. We tested it in very dynamic environments like trade shows and fairs where lots of people are around, and it performed very well. Also, it's like running in standard operation in a couple of other factories with that setup. So that's a solved problem, I would say, for AMRs so far. So no issues with that.
Okay, good. There's one more question. I think that's maybe even related to myself. Does the inspected part always needs to be exactly on the same spot? Actually, no, as we are always able to do a pre-alignment or an alignment before we do the measurements. So the complete solution, as we have seen it with the HUV, is that we locate the laser roughly at a known position, depending on the requirements. It could be some millimeters or sub-millimeter accuracy. But to achieve the highest accuracy, we can also use some alignment points, tooling balls, or features on the part to make the fine adjustments. And in the worst case, we can even use larger parts of the scanning or of the part to align to the part. So we should have a rough idea where we have the part, but it's not, there's no need to have it exactly on the same spot. So there is some variation possible. I hope this answers your question. And there, well,
that next one actually, I think, relates very well to what you just said. So reproducibility and validation, basically, that goes hand in hand with everything being the exact same spot or not, right?
Yeah, it's more or less in the same direction as the technical specification for the complete system depends a little bit on the range, the size, and the environmental situation. And we did some tests. I just see, have you made any official repeatability and producible tests? We did some setups and some tests with some applications and found quite good values for it. I would suggest that we may discuss offline what is the requirement and what you are looking for, so we can go a little bit more into detail. And how to determine the measurement points. That's maybe also to me. No, actually, if you work with a laser, it's a quite simple measurement task. So we define the scan area. We do the scanning with a single beam scanning of the surface. And at the end, all the point clouds can be moved over to the third-party software or to analyze the software. It's a quite simple approach. And also here, feel free to reach out to me for further details, as then we can discuss a little bit more in detail if you have further questions. Then we have
new question in the chat concerning the API specification.
Yeah, I just see it. And I'm wondering if you talk about a laser tracker or about the LiDAR, because what is the best measurement precision we can get using an API laser tracker on 4-meter length inside a closed room with constant temperature conditions? For sure, the environmental condition looks quite good. I'm not sure if you are referring to the LiDAR or a laser tracker. Today we showed the LiDAR, so I assume you are talking about the LiDAR. Please correct me if I'm wrong. The LiDAR has an accuracy of 25 microns plus 6 microns per meter. That means we have about 50 microns in a range of 4 meters from distance from the system. I hope this answers the question. Okay. Good. Excellent. Yeah. Are there more questions? So right now, let me see. There's one more question also related to myself or to API. Do we have specific settings to measure certain feature holes, slots, depths, and gaps? This is always related to the third-party software, how the third-party software is implementing such kind of measurements. So in this case, yes and no, depends what kind of software you are using. But we can also discuss this one a little bit more in detail offline. So our contact data are visible here on the screen. Send me an email or call me on my mobile, and we can look into the exact details and the requirements of your application and the question. Okay, there is one question for you, Stefan. What exactly 11 Dynamics does? Could you give more information? Maybe just recap what you are doing.
Yeah, we provide the software platform to connect everything or to build up a digital twin, do the simulation in our software to get, let's say, quality of the data, cycle time, visibility, things like that. Then we can do path planning and everything in our software, in this case, the path planning for the AGV or AMR. And then we can drive the real system with our software and control it. And forward the data to the inspection software, whichever you are using, because we are quite open in this case to support more or less any major software on the market. I hope this answers your question.
Can you use Stefan?
This is a good question. I have to verify it with our development team if we already have this interface implement. It's not. I know that it isn't implemented right now, but how far we are. So maybe if you can send me an email or give me a phone call so that I have your contact details, I get back to you later when I've got the information from our development team.
Okay, so
I think we missed one question. One question is about without the robot, what are the maximum dimensions of a part to be scanned?
yeah, I just scrolled down and saw it. I think that's related to API. At the end, the laser can measure up to 25 meters in the radius. So with the quite high incident angle, I would say if you measure to both sides, that can be up to 50 meters or 45 meters in total. So it depends a little bit on the size, the feature to be measured, and mainly it's the surrounding or the location itself which limits the scan. But the instrument itself can measure up to 25 meters. So I think this answers the first question. There's one more. Could this system can be used outside? If it is just about the laser, it is IP52 protected, so you can use it also outside. But if it is rainy or you have really, let's say rainy, the laser beam will be sometimes affected by the laser raindrops. So the answer is yes, but not at rain because of the laser, not because of the system.
Our software is working outside.
Depends on the computer, right?
Yeah, it depends on the computer, but it's working outside.
What about the Neobotix? Is it
robot,
working
yeah.
outside?
I mean,
If it is
like
flat?
the surface is is good enough. Also like even enough. It can also run outside even with a bit of humidity. So So technically, we can make that happen. Yeah. Let's see about this application and the surroundings and the environment in detail to give a precise answer. If you want to go into the woods or into a field with like a completely uneven floor or yeah, even a bit of slope there, it complicates things a lot. But yeah, let's discuss.
Okay, good. So I just need to double check here again all the channels, but I think we more or less answered all the questions so far, at least. I'll wait a few minutes here. Okay, yeah. However, if you have any further questions, feel free to reach out to us. Depending on the question itself, you may reach out to Stefan, to Felix, or myself directly. And if you are not sure who is really responsible, send it to whom you ever want. Stefan, Felix, and I can share the information and make sure that you will get the answer you are asking for. So last question here in the chat. There's one question about the budget. Can you give us an idea of the budget? This is a quite difficult answer because it depends on your real application. So it depends on the size of your part. It depends on the system you want to use. It depends on the robot you need. There's too many different details to be clarified before we can really give you a budget. But feel free to reach out to us. We can review your application and give you an estimation of the costs, which fits to your own application. Okay, good. Time is running. We are at the end of the webinar. Stefan and Felix, I really want to thank you for your support here on this webinar, for the opportunity to make this nice discussion. It was a pleasure to meet with you and discuss about the different systems and software we have and how we can combine into a quite interesting solution. We see a lot of questions raised up from the audience. Thanks to the audience for the questions and your participation. And feel free to reach out to us on our email address or on our phone numbers. And I guess I speak for Stefan and Felix as well. We are really happy to support you and see how we can help you.
Yes, correct. Send us your questions and requests for demos and so on. We are here to support you.
Excellent. Okay, this said, I would say have a nice afternoon. Looking forward to meet you, or maybe we can meet for a demonstration or at least for a nice conversation by phone or by a video conference. And yeah, have a nice day. Thanks.
Thank you. Have a nice day. Bye.
Thanks. Bye-bye. Ciao.